Hello everyone. So today we will be solving maximum level sum of binary tree. So this question is quite simple. Like basically you have to do a PFS traversal and that- that's it. There is like two little tricks which I will be teaching you. So what does this question says? So basically you have to give the maximum sum. Like you have to like basically you have to give the level at which you have the maximum sum. So like here you can see that at level one we are having only sum as one. At level 2 we are having sum as 7 plus 0 which is 7 only, and at level 3 we are having minus 1. So our maximum level sum level will be 2 in uh, only one test case is here. So basically and the sum is calculated by adding up all the nodes at that level. So if I draw it, like for level 1 the sum will be 1, for level 2 the sum will be 7 plus 0 which will be again 7, for level 3 it will be minus 1. So like we have to return at which level we get the maximum sum, which will be at level 2, right? So so like we can see that we have to basically do a level wise traversal, that is BFS. So for doing that, what we can do is that we can basically use a queue and just traversal using that. Like there are multiple methods of doing it. So like all of them use queue only, but like you want to know that at which point does your level end. So like there are multiple ways. You can just add null value representing that there is this point ends this level. So if you don't get it, don't you worry. Let's get started, and like I will be explaining you like what I'm doing along the way. Queue of Let's create queue of renode. It's called new array PQ. Now now basically what I'm doing is that I'm initializing array dequeue. So array dequeue doesn't like it cannot store null values basically. So array dequeue would not be useful if you are storing null values to indicate that your level ends here. So for that, you can just array you go to new linked list. You can just basically use linked list, and you can do it by that manner, or else just implement array queue. And like this method is quite simple compared to putting null values at the end of your queue. So what we can do is that while queue dot size is greater than 0, so we will be doing this until our queue becomes empty. And like initially queue is empty, so first we have to add our root node. And we have to also initialize level. Int level equals to level is 1 base. That's why we will be initializing it with 1. So what we can do is that we can capture the size of queue at that particular moment. So int size equals to queue dot size for int I less than size. So what basically this is doing, like this for loop will be traversing throughout each and every level basically. So like initially let me do a simple dry run so that we can understand very easily. So what we can do is that let me run through like how the entire process is working. Okay. So initially in queue we have root node which is one, right? So in this loop, and initially the size of queue will be what, one, right? So initially this loop will be running for only one time. Like this loop will be running for only one because we have only one only one node inside our queue. So what we can do is that during one node, what we can do is that we can basically remove that node from the queue. So the node, let's call it node, you have to remove node, whatever you want to call it. Uh, and we have to like we have to create few checks. Like if node dot left not equals to null, then q dot add node dot left. Similarly, we will be doing this for right also. So and what we can do is that we can basically create a temporary variable which will be storing the sum of current level. So it will be initialized with 0, and current equals to current plus equals to node dot var. Okay, so let me explain you what like this code is doing right now. Like, these two loops. So what? basically I'm doing here is that first I'm capturing the size of q at that particular instance. So during first iteration, the size of q will be 1. So this loop will be running only for once. That will be so initially what I'm going to do is that q dot remove. So initially q just has only one node, that is root node. So I will be removing that q node, and if left not equals to null and right is also not null, so I will be adding both of them. So first left will be added, then second the right will be added. Okay. Now and our current sum variable is also like that, and in our current sum the value will be like 1 initially. Current sum has given us like the sum of that level will be 1. Okay, so we have traversal for the level 2. Okay, so now what we're going to do is that again I will be looping over and like on the first stage what basically I'm like on first iteration what basically I did is that I traversal on level 1. In second iteration I will be going through level 2, and similarly I will be going through each and every level. So this for loop basically enables me to iterate through each and every level, and that's why we have like this static this static not a static variable, but like not static variable literally, but a variable named size which will be remaining same throughout this iteration. Like what if let's say okay, let me undo it. Let's say if I run this loop from instead of running till the variable size ends, let's say if I run it from q dot size, like right. So this size will be always updated, right? Because I am removing one node, I'm adding multiple nodes. So like it will be giving you some error mostly, or else you might get wrong answer. You wouldn't be able to traversal through the same row. Like let me run it and let's return. Okay, so you didn't get any error, but basically what this q dot size is like, dynamic in nature. It will be incrementing, it will be decrementing, so we cannot rely on it. So basically we have to capture the size of q at particular instance and loop from 0 to that size. So okay. Hmm. Now let's this is like simple BFS traversal. You can just copy this code and use it again and again if you want to do any level or a traversal. So now let's solve this particular sum, which should be like quite simple. Only the the part which you have to implement was this one, and you have to now you have to just make 2 3 variables and call it a day. Int so let's initialize int max sum equals to integer dot mean value. So I'm initializing it with negative infinity at this moment. Okay, and int answer level equals to 1. So what I'm doing here is that like this answer level will be the answer which we have to basically return here. Return answer level, and the max sum will be the sum which captures the maximum sum. So like during level one, the maximum sum will be infinity, so it will be updated to 1, and the best potential answer will be level 1. But we will be again traversing deeper into the trees for finding even better answer. So that's why we are using these two variables to capture the maximum sum, and and the level at which that maximum sum was found. So like after the level order traversal, what we can do is that if current is greater than max, then update the max equals to current, and answer level equals to this particular level, and increment the level like after each loop, basically increment the level. Let's run it. There might be thousands of compilation error. Here we go. Oh sorry, not max sum. Let's submit it. It got accepted, and we are again. Yep.